Hello and welcome again. And today I have a very interesting topic in the series that is called NLP Fundamentals, that is Natural Language Processing Fundamentals. And the subject you see the highlighted as a complete beginner friendly. But it is not only beginner friendly, but it contains the core concept of the NLP before we proceed in the deep depths of the NLP models and algorithms. What you learn out of it is that what is NLP, how computer understand this one, right? So, and real world examples in that one. It means today we are exploring the fascinating world of natural language processing. This is a technology that allows computers to read, understand, comprehend, and even generates human language. Whether you are a beginner, as you said, or just curious, end of this video, you all know how NLP is being or transforming the AI world just for a talk, listen, and write like humans. And this is all NLP behind all this. Okay, so before doing any further delay, let's go to the in a basic crux. What is the NLP? What is the natural language processing? And sometimes in the people also been talking about the natural linguistic processing. Okay, that is not absolutely, people just do jargon sometimes over the lot of videos and the YouTube's around, but we have to be very very clear about to understand it correctly. Now the question is, what is the natural language processing, as you see on the pictorials and the slide. Okay, so just give you the brief. NLP is how the computers learn to handle language. Think of it like you are teaching your friend English. First they learn vocabulary, then grammar, then context. Once they understand those, they can respond accurately and correctly. Computers do the same thing, but with the algorithms and models. And NLP powers everything from a spell check to the real-time translations. And that is what you see in this pictorial, that first thing in the process of NLP, natural language processing, is like humans, it does reading, it does read, comprehend the text what you provide to the algorithms as an NLP. It can understand, can create and write the contents based on what you provide, and then it can generate maybe text output, or maybe based on the requirement it can create voice and speech processing outputs as well. Okay, now this is a very fundamental, okay, just to understand that means how to process the data further, just like human beings. Okay, now the next question very in front is that why NLP matters today. Okay, here is why NLP is important today. First thing, as you see on the pictorials, that is what I have been observed from the different articles and sources, that 80% of the business data is unstructured. Okay, whatever we are doing right now, 80% of the data is unstructured, and you can see in the cluttered, because this has not been organized data. Okay, second thing, that we have more than 7,000 languages spoken worldwide, and NLP market is projected to reach $43 billion by 2025. I don't know if it has been, the numbers are correct, but at least this has been very huge. So NLP is behind search engines, chatbots, translation apps, email filtering, sentiment analysis, and even the content generation. So NLP is been very vast. Okay, as you see this one on my slide. Next chapter, which is really key to understand the evolution of NLP. Okay, so let's take a quick journey through the history. As you see on the screen, what I see is then in 2000, feed forward network processed text but could not handle the sequential data. Okay, and that was a very very foundation of this NLP processing. But this was the key breakthrough in the NLP. Okay, in 2013, if you look, the word to vector introduced word embedding letting computers understand word meanings in the context. And that was been wonderful technique. Under this technique, what we call also been used Kabao and the script grams. Okay, we'll not go into deep it, but further we can discuss about it when we go deep on the NLP. Then you go next into it 2014, the CNNs and RNNs are improved sequence handling, which is not there in 2013. Okay, so that, and what we call it is a convolutional neural networks and recurrent neural networks. Okay, and in the same series, if you go further, I mean, we have done advancement in 2015, attention mechanism that allowed models to focus on important words. That means we have been reached extra miles in 2015. Then in further sequence, we look at if you look at in the further sequence, sorry, we have 2017 transformer chain everything. Okay, and by 2018, the pre-trained models like BERT and GPT revolutionized the NLP, achieving state-of-the-art results. Okay, now in the same function also, what we got is transformers. Okay, that we go later in the next video. Transformer basically now the crucial part of the NLP relies on self-attention, multi-headed attention, learns grammar and structure all at once. The decoder uses the mask attention, so it generates the text by step. Okay, so that is basically now transformers is encoder decoder sequence. How encoding and decoding happens before it translates that into your output. Now, the next question is why NLP is crucial for the business. Why NLP is crucial for the business? If you see, there is four pillars what I mentioned: customer insight, decision making, automation, and competitive advantage. For business, NLP is a game changer. It helps analyze customer feedback, automate support, make smarter decisions. Companies can uncover sentiment, identify pain points, and streamline operations. Those who adopt NLP gain efficiency, innovation, and competitive edge in the technological advancement. Okay, now you see, so in today's data-driven landscape, mastering NLP is no longer an option but a strategic imperative for any forward-thinking business and customers. Okay, now NLP can be categorized further into different tasks, and this is very essential now before we learn and we understand how NLP basically works. Now, if you look at the core NLP task, right? Okay, so core NLP task is about tokenization. If you see left hand side, part of speech, that is that what we call pause tagging, named entity recognition, that we in short form we call NER. The next is dependency parsing and lemmatization and stemming, or you can say text classification, sentiment analysis, and machine translation, and then stop word removal. Okay, these are the abstractions which basically NLP works upon. Okay, now if further I go before in the next chapter, so what we understood from these key foundation blocks is each these tasks build toward computers truly understanding and generating human languages. So behind the output what it generates like humans, and maybe the smart output, this is the key process left and right. Okay, so the very left is the very one, the tokenization, pause, NER, dependency parsing, lemmatization, and the stop removal. These are the key sequence. Let's go deep into it. The very first step what we talk about is what is tokenization. What is tokenization? Okay, now, okay, so tokenization is a process of breaking raw text down into smaller discrete unit called tokens. Tokens can be individual, words, subwords, units like ing or un, characters, or even punctuation marks. It is one of the very first crucial step in almost any NLP pipelines and NLP formations, enabling machines to process and learn from natural data effectively. Now, why tokenization basically the subject is, and the question arises why. Okay, because the first thing is numerical representation. The computers, we know from ages, the computers at their core do not understand not do not understand the do not understand the text. They can only understand numbers, not abstract human words. Okay, that is what I mean. So tokenization is the gateway that converts human readable text into the format, a sequence of tokens that can be further mapped to the numerical representation. So in a very layman form, you can say the computers can only understand the zero and ones, right? The binaries, that means numbers, and same happens with the NLP. So that what we call numerical representation under the hood of tokenizations. Okay, so without this step, machine cannot read or process languages. Second is simplification. What that means is, imagine trying to process the continuous stream of the characters without any breaks. So thereby the tokenization simplifies text for analysis by segmenting it into the manageable and meaningful chunks. So after all, tokenization is the foundation and foundational step that transforms the raw unstructured text or data into the structural sequence that machine can understand before it interprets and produce the output of the complex sentences. That is what it is. Okay, now let's go the next foundation pillar. Okay, before going to the next foundation pillar, okay, this is a great example. What I quoted is about how tokens basically works. Breaking text into the individual units, that what we call tokens, that computer can process. For an example, there is a sentence, natural language processing is amazing. Okay, and this is the input sequence. So this is the input for machine NLP. And how does it work basically? It breaks down the entire word into the into the different parts, what we call tokens, like in a natural language processing as amazing, and then this is punctuation. Now again, when you talk about the tokenization, basically there also been subset of the tokenization, what we call as word label tokenization. That means split by spaces and punctuations, like I love NLP, so it does I love NLP. So each of the word has been segregated by the punctuations. Second is the character label tokenization. For an example, each character is a token, NLP. So NLP has been further broken into N, L, and P. The third form is, that is what we call sub-word tokenization. That means balance between word and characters. For an example, there is a big word, unbelievable. That means on, believe, and able. These are different, what we call as being segmentation of this huge word, so it can understand. So in a nutshell, tokenization is the first step in any of the NLP processing or NLP pipeline. Next, go to the next chapter and next process, the step 2, text processing. Text processing is basically very crucial. uh, Text, that is very crucial in a sense, cleaning and normalizing text for the better analysis. Let's process the cat or playing. If you see, first of all, what it does in the step 2, in the processing unit, NLP does lowercasing everything in that given sentence, if you see that. Okay, the second thing is remove punctuations. Okay, so if you see that it has been removed, that last and the punctuations in that sentence. Third one is then remove stop words, like cats are playing, so R is a stop word, it has been just removed. So you now cats and playing. Stemming is a process to reduce root form. Okay, so cats playing, cat play. This is a root form. Okay, now stem versus lemmatization. What is stemming? We can cover that in the next practical video next time. Stemming is, for an example, running. There is a different forms, right? Running, runs, ran. Okay, but the basic root of it is the keyword is run. That is a crude rule based stemming lemmatization. Running, runs, ran. Again, run is basically the very base and root word that uses dictionary. The dictionary in a context of language dictionary, that is more accurate to utilize. Okay. uh, Now, okay, if you look at step 3, the part of speech tagging, that is POC. It is just purely grammar. Okay, the part of speech, how grammatic English grammar works. In the same form, it used that identifying the grammatical role of the each word in the NLP processing. Third step. This is what it does basically practical in the backend. Take an example: the quick brown fox jumps. Okay, uh, the the very for the word is determiner. Quick is adjective, brown is again been adjective for this, in this sentence. Fox is a noun and jumps is a verb. Okay, so this has been broken all the pieces, all the sentence into pieces, and has been given them different assets, like what is the determiner, adjective, noun, verb, pronoun, whatever. Same like grammar, usual grammar. Common pause tags. For an example, if you see, right, if you look at what is a part of a speech, like in a noun, you have verb, adjective, then you have been determiner, and then you have been pronoun. Okay, and there is an example I've been quoted. You see that. For an example, Paris is a place and location, that has been a noun again. Person, place, or thing. Adverb, action or state, verb. Okay, any action you see in the sentence or any state that will be covered in the verb. Adjective, that describes basically nouns. Okay, like Paris is a place. And so this has been purely grammar based translation in the algorithmic level. So pause tagging help understand sentences structure and meaning. So that is how NLP basically works. Before doing further delay, next go the very vital step of this NLP, that is the named entity recognition, that we in short form you'll see that people calling it NER. Okay, so finding and categorizing the names, places, organization, and a text. I'll give you an example, a fantastic one. The Barack Obama visited Paris on January 20th. Okay, so if you say recognize entities, what we got out of it is Barack Obama is a person, Paris is a location, January 20 is the time. Perfectly bifurcated in the algorithmic sequence in the backend. Common entities type, what we could see: person, place, location, organization, time, money, etc. So used in information extraction, question answering, and content classification, because that is how you can bifurcate these name entities into the different piece of it, that what NLP does. Now, without any further delay, the step 5, this is a core pillar: dependency parsing. Okay, what is the dependency parsing? So if you look at the example, the cat sat on the mat, and then you look the complete structure, right? Complete structure, you will know about it. Yes, like for example, if you see the word sat is the root or verb. This is a very common. Then you see the noun cat, then you see the adjective uh, on. Okay, so and in this sentence is the determiner, what we already learned about it. Okay, so everything has been converted, and if you see the left to right is into the a smaller one. So the what we learn about this, the parsing, basically the common dependency relations it maps, like the nominal subject, like who does the actions, receive who receive the actions, what is the preposition, that what we call relationship between each other in the sentence, what is determiner, like the and this adjective. Adjective modifier, I mean, that describes the noun. Same with adverbial modifier, describes the verb. Okay, so this is completely based on the grammatical, sinology and syntactic. So but this is very, very, crucial to understand this parsing. Now, now we learned so far about it. Now, if you look at the word embedding, that comes in the later stage of transformers. So that means representing word as a numerical vectors, because we already learn about it. Computers and NLP as a whole do not comprehend and understand the textual data. They only understand numbers. If you say cat and dog, this is all garbage for the machines. And for NLP, what they does is word embedding map words to the vectors. That means they does text into the numerical representation via using the different embedding methodologies and vectors. For an example, we already been talk about word to vector, that was in a sequence of evolutions learning word embedding. So this basically word to vector models, what it does is algorithm, what it does, it learns word how the word representation by predicting context. Similar word appears in the similar context, so they can get the similar vectors. If for an example, if you see the key properties, semantic similarities, like king and queen, those belongs to the same, they have the similarity because they are from the royal dignitaries. Arithmetic evolution, if you see, and the key properties, that means king, king means king has a relation with the man, with the male, while the woman, the queen has the character of the woman. Okay, so there have been arithmetic explanations in the backend, and same goes for the dimensionalities. Okay, so embedding captures the semantic relationship between the words. So this is a key role, this very, very key role, that it plays the relationship, semantic relationship between the different words, and that is how it memorize and keeps those things in the mind before it reproduced, and produce the outputs. This has just been so NLP in a concept visualization. Basically what we already been learned about is that if you look very briefly on this, the first becomes the part of the speech. Okay, how this works, every sentence broken down in the pieces, and then it has been tagged with whether it is been a pronoun, it's a noun, verb, adjective, and what not. So it has been a grammatical sequence in the NLP. NER, we talk about it like Barack Obama is a person, Paris is a location. So we got it from the NER. We got two things: the person and place. Dependency parsing, yeah, of course. So dependency parsing shows the grammatical relationship between the words. Okay, so Barack Obama is a compound word. Again, yeah, you know about it. We don't want to talk more, but you see in this one, so this is basically it has just been, you know, showing the dependency relationship between the word, how this has been interconnected, and how this has been formed. The, the tokenization is a process that what we call as been context window, right? So define the scope of the text in NLP model process at once. So if you see that means entire sentence has been broken out into different four pieces, and that every piece in this process is called a token, process as a token, and further token has been processed in a parameter, and those are the numeric representation again. Now without any fuss, look at the high level of NLP task, what it can do. The first thing, question answering, it can do the text summarization, it can be used and being used as a dialogue systems. So in the commercials, in the companies, you see they are using the chatbots. If you go in a different sites nowadays, you already have been seen that there's been chatbot already been enabled, and they are saying, can I help you out, right, in that sense. Okay, so these are the smart modeling and algorithms which NLP is doing in the backend. What you see, question answering. So if you look at syntactic and semantic analysis and deeper understanding, what happens, parsing, the fundamental process that determines the grammatical structure of the sentence, identifying the subject, verb, object, whatnot, and then relates them to each other. It's like building a grammatical tree for each sentence what you have given to the NLP. Syntactic analysis, semantic analysis goes beyond grammar to understand the meaning of word and sentences in the context. It before it generates the output, right? So this is a higher level of extraction what it does nowadays. NLP in action, if you see what we are using and utilizing in XP nowadays, as in the search engines like in Google, you have Bing, you have been many more. The translation, Google translation more than 100 in languages. Email filtering like spam detection, categorization. If you see uh, anywhere in a Gmail, that has already been available. Chatbots, sentiment analysis, autocorrect spelling, assistant like your Siri from Apple, Alexa from Amazon, Google Assistant, and so forth. Text summarization, news summaries, document insight, and content creations. So, getting started with NLP, how we can hands-on with the NLP so you can really understand the crux of it. How does it really works in the backend? And the prominent, very prominent, library that is NLTK, natural language. These are the toolkits for the natural language processing, which are very comprehensive and also been educational. So you can given that one of the command if you are using Linux machines, you simply can do pip install NLTK if that supports your OS. For an example, CentOS and RGL. So what NLT does is it has been prominent library for tokenization, post tagging, stemming, parsing, limitations, and many other functions. In the similar form, you have been is sparsely that basically used for the parse again, NER, dependency parsing, and word vectors. Text velocity, yes, I mean basically this is very prominent library as well again. Simple NLP, beginner friendly as well for the sentiment analysis, translations, and post tagging it also does. And then Gensim, okay, this is the topic modeling and word embedding basically. So what we talk about is word to vector. It also uses it in doc to vector topic modeling. So these are the precisely I've given you these few libraries, and very prominent one in the market, in the commercial as well. So please go through it. And NLTK is the very first one which has been very interesting, and you can just, if you know the Python, I think you will love it. Okay, so in next session probably we'll just explore NLTK and give you the hands-on understanding how this tokenization, pause, limitations, systeming, all this basically works. So learning resources you can freely available. You just go on the website and see NLTK books are freely available. I'll just put the the comments, those website links which you can use from the different sections. Even there has been very prominent videos been available in Coursera. Even you can go the Stanford courses. They have given the full lectures on the NLP and as a whole on the AI, including LLMs and deep in the structure. So what are the key takeaways out of this course is what you should remember from this course is NLP enables computers to understand and generate human language through the mathematical representations. Tokens are input and output units. Parameters determine model capacity and capabilities. Transformers revolutionize NLP with attention mechanism and parallel processing. So model LLMs are trained on the massive datasets and can perform diverse tasks through prompting. So LM we will cover in the later one, but these are the advanced form of the NLP itself in a generic term. Application ranges from the chatbots to content generation, translation, and analysis. Challenging include hallucinations, bias, and so on. The field is rapidly evolving, like in a multimodal, agentic, efficient models. The future NLP, emerging trends and opportunities. Multimodal, like understanding text, images, video, audio together. Examples: GPT version 4, Gemini. Agentic AI, we know about it. Long chain agents, reasoning models, better logical reasoning, math problem solving, chain of thoughts, efficiency. Smaller, faster models with a similar capability like the large ones. That has been pretty, uh, efficient. Edge development. Okay, running LLMs on devices, phones, and laptops, and even vehicles. Domain-specific models, fine-tuned for for the industries which can run the specific which can generate specific orders based on your demand. That is where the NLP's future is. So see you guys soon in the next chapter with the hands-on practice and some uh, key aspect of this what we cannot cover in the one video. So thank you so much for looking at this video, and I hope you guys enjoyed it and you will get something out of it. Before we go hands on, please do subscribe and also process this video. The other learners who want really been keen on these topics will keep on slowly getting into the context and hands on. So thank you so much, and please do subscribe and forward this to your friends and colleagues. Hope this make you some learning out of it. See you again and have fun. Thank you.